Imagine falling into the most mysterious object in the universe. A place where gravity becomes so powerful that not even light can escape. A place where space and time begin to behave in ways we barely understand. This is a black hole. But what would actually happen if you fell into one? Black holes are born when massive stars reach the end of their lives. When these stars run out of fuel, their cores collapse under their own gravity. The collapse is so powerful that all the mass of the star is compressed into an incredibly tiny region of space. What remains is an object with gravity so strong that nothing, not even light, can escape its pull. These strange objects were first predicted by Einstein's theory of general relativity more than a century ago.
The very fabric of space and time.
For a long time, scientists believed black holes were only mathematical ideas. But today we know they are very real objects scattered across the universe. Every black hole is surrounded by a boundary known as the event horizon. This is the point of no return. Once anything crosses this invisible border, escape becomes impossible. Even light cannot travel fast enough to escape beyond this boundary. If you were watching someone fall toward a black hole from far away, something very strange would happen. As the person approached the event horizon, they would appear to move slower and slower. Eventually, they would seem almost frozen in time. This happens because gravity near a black hole is incredibly strong. According to Einstein's theory of relativity, gravity affects the flow of time. The stronger the gravity, the slower time passes. Near the edge of a black hole, time begins to stretch and slow dramatically. From the perspective of the falling astronaut, however, time would feel normal. They would continue falling toward the center without noticing anything unusual about time itself. But the deeper they fall, the stronger the gravitational forces become. And soon another strange phenomenon begins. As you approach the black hole, gravity becomes uneven. The force pulling on your feet becomes much stronger than the force pulling on your head. This difference in gravity is called a tidal force. These tidal forces would begin stretching your body. Your body would become longer and thinner as gravity pulls it apart. Scientists call this process spaghettification. Anything falling into a black hole would eventually be stretched into long streams of matter. Even stars can be torn apart this way if they get too close. Surprisingly, crossing the event horizon might not feel dramatic at all. There is no solid surface or visible wall marking the boundary. From your perspective, you would simply continue falling deeper and deeper into darkness. But once you cross the event horizon, there is no possible path back to the outside universe. Inside a black hole, our understanding of physics begins to break down. The laws that describe space, time, and gravity no longer behave in familiar ways. Some physicists believe that inside a black hole, space and time may swap roles. Moving forward in time could become the same as moving toward the center. In other words, reaching the center may be as unavoidable as moving forward through time. At the very center lies something called the singularity. This is a point where density becomes infinite and gravity becomes infinitely strong. All the matter that fell into the black hole may be compressed into this single point. But the truth is, no one actually knows what happens at the singularity. Our current theories cannot describe the conditions there. The equations of general relativity break down completely. To understand what truly happens inside black holes, scientists believe we need a new theory that combines gravity and quantum mechanics. Another fascinating idea suggests that black holes might be connected to wormholes. Wormholes are theoretical tunnels through space and time. If they exist, they could connect distant parts of the universe. Some scientists imagine that falling into a black hole might lead to another region of space through such a tunnel. Others speculate that black holes could even connect different universes. However, there is currently no evidence that wormholes actually exist. Another deep mystery involving black holes is called the information paradox. In quantum physics, information about physical systems can never truly be destroyed. Every particle carries information about its state. But when matter falls into a black hole, that information appears to disappear forever. This creates a major conflict between quantum mechanics and general relativity. So, where does the information go? Some scientists believe it may be stored on the surface of the event horizon. Others believe it might slowly leak out through radiation. In 1974, physicist Stephen Hawking made an astonishing discovery. He showed that black holes are not completely black. Due to quantum effects near the event horizon, Black holes slowly emit energy. This phenomenon is now known as Hawking radiation. Over extremely long periods of time, this radiation causes black holes to slowly lose mass. Eventually, after trillions upon trillions of years, a black hole could completely evaporate. Black holes are not rare objects. In fact, astronomers believe there may be hundreds of millions of them in our galaxy alone. Most large galaxies contain a supermassive black hole at their center. These enormous black holes can have masses millions or even billions of times greater than our Sun. The supermassive black hole at the center of our galaxy is called Sagittarius A star. It lies about 26,000 light-years away from Earth. Even though it is invisible, astronomers can detect its presence by observing the motion of nearby stars. These stars orbit an unseen object with enormous gravitational power. Some supermassive black holes also produce enormous jets of energy. These jets shoot out from the regions around the black hole at nearly the speed of light. They can extend thousands of light-years into space. These are among the most powerful events in the entire universe. When we look at the largest scales of the cosmos, we see something remarkable. Galaxies are not randomly scattered across space. Instead, they form vast networks of clusters and filaments. Scientists call this enormous structure the cosmic web. Across this immense cosmic structure, black holes help shape the evolution of galaxies. They influence how stars form, how galaxies grow, and how matter moves through the universe. The universe itself is unimaginably large. There are billions of galaxies, each containing billions of stars. And within many of these galaxies lie black holes silently shaping their surroundings. Even with all our discoveries, black holes remain one of the greatest mysteries in science. They challenge our understanding of gravity, time, and the nature of reality itself. And somewhere in the depths of the universe, countless black holes continue to exist in silence, hidden behind their event horizons. Perhaps one day humanity will uncover the true secrets of what lies inside them.